Hi guys, today we're going to see the insert delete get random of one problem. This is LeetCode 380 problem. So as you can see, this is a medium problem, and let's quickly jump to the description. So it says that design a data structure that supports all following operations in average of one time. So insert val inserts an item val to the set if not present, and remove val removes an item value from the set if present. And get random returns a random element from current set of elements. Each element must have the same probability of being returned. For this we can use the standard random class which is available in Java. Okay, and let's quickly take a look at the example. So if you see in it an empty set, randomized set, random set equal to new randomized set, and random set dot insert one. So on the right hand side, if you see that we have got a class randomized set, and we've got this boolean insert method. So they're basically instantiating this class and you're just calling it with the insert. They're basically calling the insert method with one. So as you can see, one is not present, right? So we're initially returning one, true, stating that one was inserted successfully. Now they're trying to remove two, and two is not there in the list, so it should actually return false. Okay, and on the right hand side, you see there is a remove method which is of type boolean. Okay, and then they're trying to get random, and you can see this get random method here on the right hand side, so it returns a random element from the set. So now we've got two elements, 1 and 2. We've inserted 2, so get random should either return 1 or 2. Okay, and then they're trying to remove 1. So once they remove 1, they will return true because 1 is present in the set. And they're trying to insert 2. 2 is a number which is already present, right? So this should return false because it's already present. And next they're trying to get random. As you can see, they removed 1, so which means in the set we've just got 2, and so get random method will actually return true. Now let's figure out how to solve this problem. They're saying that insert, delete, and get random, all these three functions should be performed in O of 1. If you remember, hash table hash map has O of 1 lookup time, but it does not have O of 1 insertion time or deletion time. A data structure that supports O of 1 insertion and deletion is linked list. So we should combine both these, and we should come up with a solution for this. So what we can do is we can have a hash map where the value that is inserted will be the key, and the index at which we are going to insert this in the list is going to be your value. Okay, so basically what I'm trying to say is we'll have a hash map, integer comma integer. Let's say it as hash map. So you can initialize it here or you can initialize it below as well. So let's initialize it in the constructor. So this is going to be a new hash. And then to support insert and delete operations of one time, we're just going to have a list which is going to have integer objects. Let's call this just list, and I'm going to initialize it with the constructor. Okay. And this get random, we can use the default random class which is available in Java. So let me initialize this as well. So we can initialize it here or there in the constructor as well. Doesn't matter. So directly what you can do is you've got a list. So we're going to insert elements in the list. So this is definitely going to return an int. So from the list, right, we have this get method. So what we're going to do is using the random function, we'll have a randint, and then basically it returns the next int. When you give a list.size, right, basically it'll return a random element from it. So this is O of 1, right? So O of 1 for get random is supported. So let's worry about insertion. Okay, now they're saying that if the set is not already having the specified element, then it should insert and return true. Whereas if it has, then it should return false. Okay, so which means if this hash map dot contains key of val, okay, this means it is already, the val is already present in the hash map, so we're going to return false. Cannot insert a duplicate element. Whereas if it is not present, then we are going to put it in the hash map. What we're going to do is val, and if you can see, I'm going to say list.size. So initially we have initialized it with new array list, its size is going to be 0, so basically we're inserting value at index 0. So to corroborate this, what you'll do is we'll add at index list dot size, which means it is 0. At 0 we're going to add this. So now we've inserted, so we'll return true. We've successfully inserted this element. Now how do we remove an element from this list? So before that, if the element is not present in the list, then you cannot actually remove it, right? So since we're putting it in the hash map, what you can do is, there is a spelling mistake here, let me correct it. So if it is not present, hash map dot contains key of val. If it is not present, then we cannot delete it, so we're going to return false. Now let me take an example to show you how we are going to do this deletion. So let's say I have inserted 1, so basically the size of the list will be 0, so 0. So in the list it is going to be 1 element, right? Let's say I'm inserting 2. Index is 1 because the size of the list is 1, so 2 comma 1 will be there in the hash map, and the size in the list will be having 1 comma 2. Okay. Now let's say I'm inserting an element 5 and its index is 2, and so in the list you will have 1, 2 and 5. Okay, so this is like insertion. Now let's say I want to delete the element 2. What we're going to do is we're going to just map it to the last element and remove this last element. How do we do that? So let's get the last element from the list. So the last element from the list is actually 5. So in the list, if you see, this is the last element. Now let's get the index of the current element. Okay, so index of current element is actually 1. So what we're going to do is we're just going to put list dot, we have a method got set. So using that, what we're going to do is at index 2, which means at index 1, we're just going to put the last element. So basically 1 comma 5 comma 5. So now 2 has been removed from the list, so which means we have to update the hash map as well. So in the hash map, what we're going to do is we're going to put the updated value. So basically we're going to insert what we're going to do is we're just going to say 5 comma 1. Okay, so this gets updated, right? 5 comma 1. Okay, so this means list is in tandem and then the hash map is in tandem. We have just got to remove this 2 comma 1 because it's no longer making sense, so we'll remove that. So in hash map dot remove the element, hash map dot remove this element. So we will remove this element. So our hash map will be having 1 comma 0 and 5 comma 1, and so in the list we will remove 5. Okay, the last element. So finally both the hash map and the list are in sync. Okay, I hope this makes sense. So I'll remove this. So we've done this, so we have to get the last element. Let's say last element equal to list dot get list dot size minus 1. This gets us the last element. Let's get the index of the current element. Index of current element, it's going to be hash map dot get of val. So we're going to update the list.set. What we're going to do is at index of current element, we are going to put this last element. So now we have to update the hash map. So hash map dot put last element comma this. So we have updated the index of the last element. So we have to remove it from the list. So list dot remove list dot size. So we're going to remove the last element because we've updated this thing. Right. And so next we'll remove this value from hash map as well. So once we've done this, we've updated the list, we've updated the hash map. So we're going to return true. Okay. So let me explain this again. So for example, 1 we'll insert it at 0, right, in the hash map. So the list will have 1. Okay. Now the size of the list is 1. So let's say I'm inserting 2. So the index at I'll be inserting 2 at 1. So in the list we'll have 2 elements, right? 1 comma 2. Now let's say I'm inserting 5. Okay, the size of the list is 2. So 2 is the index at which 5 is inserted. So the list will be having 1, 2, and 5. Now I'm asked to remove 2. So what is the last element? Last element is 5. Okay. What is the index of the current element? Index of 2 is actually 1. Right. So in the list, what we are going to do is at index 1, we are going to put 5. Okay. So at index 1, we're going to put 5 here. Now you see in this list, we have successfully removed. So in the hash map also we have to update it, right? So what we're doing is now this value of 5 is at position 1. So in the hash map we'll update at 5 is at position 1. Okay. So now that these are done, we can go ahead and safely remove the last element. So remove the last element. So basically we'll remove 5. So once we do this, then we can successfully go and remove the value 2 from the hash map. So this will not be there. Okay, so which means 1 is at 0. Yes, of course 1 is at 0. And 5 is at 1. Yes, of course 5 is at 1. So thus we've removed it. Okay. So this is how deletion works. Let's quickly run this code. Line number 15 has a spelling mistake. Okay. Line number 25 contains key. Okay, it's not contains, it just contains key. Okay, so get ran.nextend. So cannot find symbol. Why is it not finding? What is the value? Okay, I've declared it as random. I'm prone to make these mistakes, guys. Sorry for that. So this is accepted. Let's submit the code. And yeah, it is accepted. So that's it, guys, for getting a randomized set operations in WOF one time. We are going to use a combination of hash map and the list, which is basically an array list. Thanks, guys. Hope you like it. Bye.